Today, we're going to be going over more of L'Hopital's rule. So, find the limit as x approaches 0 of 4x cubed over 2x squared using L'Hopital's rule. I know you could just simplify this by canceling out x's and dividing 4 by 2, but the point is to use L'Hopital's rule. So, try it out using L'Hopital's rule and um, yeah, come back once you're done or you're stumped. Alright, so if you plug in 0, you're going to get 0 over 0. And so this is one of the forms that we can use L'Hopital's rule for. So if you use L'Hopital's rule, you'll get 12x squared over 4x. So like we took the derivative of the numerator and the denominator and then divided the derivatives, and we got 12x squared over 4x. And if you plug in 0 for this, you're still getting 0 over 0. So what do? You use L'Hopital's rule again. So using it again, you get 24x over 4. And then if you plug in 0, you're going to get 0 as your answer. And so that's our final answer. The limit as x approaches 0 of 4x cubed over 2x squared is equal to 0. So yeah, every time if you're gonna repeat L'Hopital's rule like we did right here, it always needs to be in one of the applicable forms. So 0 over 0, that's one of the forms we can use. So remember, if you are going to repeat L'Hopital's rule, you better have had the limit previously in one of these kinds of forms. So, yeah, we use L'Hopital's rule, say this again. L'Hopital's rule, not the quickest way of solving this problem, but it worked because our conditions for using it were met. Let's look at some practice problems. Okay, so go ahead and try these out on your own. So, yeah, please pause the video and come back once you're done or you're stuck. Alright, so for the first problem, get 1/6. And the reason is because if you were to take the derivative of the top and the bottom, you get 4 over 2x, and then you get 4 over 2x, and then if you were to plug in 12 for x, you would get, this is your final answer. You get 4 over 24, and then it simplifies to this. Then for problem 2, the answer is going to be 0, and you didn't need to use L'Hopital's rule for this. But if you did, you would have, for one thing, you would have been wrong. Because if you were to try using L'Hopital's rule, tan of x, if you plug in 8 for x right here in tan of x, it's not going to be 0 or infinity. And well, while the numerator is going to be, if the numerator is 0, then the denominator also has to be 0 in order to use L'Hopital's rule. But it won't be 0 when you plug in 8 for x in tan of x, so you couldn't have used L'Hopital's rule anyway. So let me actually rephrase this. Don't need. Instead of saying don't need L'Hopital's rule, I'll say can't. So yeah, you could have just plugged in for x, and you would have gotten 0 in the denominator and a non-zero real number in the denominator. So yeah, our answer is 0. And then for our limit as x approaches 0 of 17x cubed over sine of x, we get 0, because if you were to, well, first of all, when you plug in 0 for the numerator and the denominator, you get 0 over 0, so then you use L'Hopital's rule, and then you're going to get 51x squared on the numerator and cosine of x in the denominator. If you plug in 0 for our denominator of cosine x, so like if you were to take the derivative of sine x, you'd get cosine x. Let me write this over here. X of 17 x cubed over sine x. Write this one more time. Get 51x squared over cosine x. And so if you were to plug in 0 in the numerator, you'd get 0. And then if you were to plug in 0 for cosine x, you'd get 1. And so you get 0 over 1, and that becomes 0. And so that's it for today. Thank you for watching, and I hope to see you back soon.